Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Exercise 8.6. Number 1. A particle moves along a straight line and passes through a fixed point O with an initial velocity of 10 meter per second. The acceleration a meter per second square at t seconds after passing through O is given by a equals to 4t minus 8. Find a, the instantaneous velocity of the particle at the 4th seconds. So when we are given the acceleration, we need to get the function of velocity. Therefore, we integral the 4t minus 8 and we get v equals to 2t squared minus 8t plus c. From the information given, when the particle passes through the fixed point O, the initial velocity is 10 meter per second. Therefore, when t equals to 0, v equals to 10. And when we sub in the 10 and 0, we will get c equals to 10. Therefore, the complete v function will be v equals to 2t squared minus 8t plus 10. So, when the particle at the 4th seconds, when t equals to 4, v equals to 2 times of 4 square minus 8 times 4 plus 10. And we get v equals to 10 meter per second. B, the minimum velocity of the particle. So minimum velocity, so we do differentiate to the velocity, dv dt equals to 0. So dv dt equals to 0 means that the acceleration equals to 0, hence 4t minus 8 equals to 0, and we get t equals to 2. So when t equals to 2, we will get minimum velocity. But what is the velocity? We need to substitute the t equals to 2 into the function of velocity. So the minimum velocity should be 2 times of 2 squared minus 8 times of 2 plus 10. Then we get 2 meter per second. Question number 2. A particle moves along a fixed point O on a straight line with an initial velocity of 2 meter per second. Its acceleration a meter per second square at t second after passing through point O is given by a equals to 4 minus 6t. Find a, the instantaneous velocity in meter per second when the particle when t equals to 3. Again, we are given the acceleration function a equals to 4 minus 6t and we need to find the velocity. So we need to integrate the acceleration. So v equals to 4t minus 3t squared plus c. And the initial velocity is 2 meter per second, which means when t equals to 0, the v will be 2. So when we sub in the 2 and 0 here, we will get c equals to 2. Therefore, the complete function of velocity will be v equals to 4t minus 3t squared plus 2. Then we need to find instantaneous velocity when the t equals to 3. So when t equals to 3, the v equals to 4 times of 3 minus 3 times of 3 squared plus 2, and we get negative 13 meter per second. B, the instantaneous velocity of the particle when a equals to negative 8. So when a equals to negative 8 will be equals to 4 minus 6t, and we get 6t equals to 12 and t equals to 2. So we know that at t equals to 2, the value of a will be negative 8. Alright, but we want the instantaneous velocity. So when t equals to 2, the v will be 4 times of 2 minus 3 times of 2 squared plus 2, and we get negative 2 meter per second. Question number 3. A particle moves along a straight line at t seconds after passing through a fixed point O. Its acceleration a meter per second square is given by a equals to 6t minus 24. The particle passes through O with a velocity of 36 meter per second. Find a, the range of value of v when the velocity is negative. So the velocity is negative, but we are given the function of acceleration. So we need to get the the function of velocity. By integrating the acceleration, we will get v equals to 3t squared minus 24t plus c. And the particle passes through point O with velocity of 36 meter, means that when t equals to 0, we'll get v equals to 36. So when we sub in the 36 and 0, we'll get c equals to 36. Therefore, v equals to 3t squared minus 24t plus 36. We need to find the range of values of t when the velocity is negative. So when v less than 0, I factorize out the 3 from here. So we get 3 times of t squared minus 8t plus 12 less than 0. And again, we factorize the t squared minus 8t plus 12. We get 3 times of t minus 6 and t minus 2 less than 0. So by solving this quadratic inequality, we will get t-axis 2 and 6 with a smiley face. So the function less than 0, we want the function or the part of the function that's below the t-axis. So this is the part. So the t is between 2 and 6. B, the minimum velocity of the particle. So minimum velocity means the dv dt equals to 0. So when dv dt equals to 0 means the acceleration equals to 0. So 6t minus 24 equals to 0, we get t equals to 4. Alright, so we know minimum velocity happens when t equals to 4. But what is the velocity? We need to substitute the t equals to 4 into the function of v. So the minimum velocity happens to be 3 times of 4 squared minus 24 times of 4 plus 36. So we get negative 12 meter per second. Question number 4. Stitching pattern on the straight edge of a headgear is done by sewing machine. The initial velocity of the sewing machine is 20 cm per second. The acceleration in cm per second square is given by a equals to 8 minus 2t, where t is the time in seconds after passing through a fold. Calculate a, the instantaneous velocity of the sewing in cm per second at the second seconds. So we need to get the function of velocity from the function of acceleration. We need to do integration. So we get v equals to 8t minus t squared plus c. And when t equals to 0, v equals to 20. So when we sub in 20 and 0, we will get c equals to 20. So the full velocity function will be v equals to 8t minus t squared plus 20. So at the instant of the second seconds, when t equals to 2, the v will be 8 times of 2 minus 2 squared plus 20. So we get 32 meter per second. B, the instantaneous velocity of the sewing in cm per second when the acceleration is 0. So when a equals to 0, it happens to be t equals to 4 seconds. Right? So when 4 seconds, what is the velocity? We need to sub the t equals to 4 into the velocity function, which is 8 times of 4 minus 4 squared plus 20. And we get v equals to 36 cm per seconds. The unit should be cm per second. C, the time in second of the sewing when the acceleration is 5 cm per second square. So when a equals to 5 cm per second square, so 8 minus 2t equals to 5, 2t will be equals to 3 and t will be 3 over 2 seconds. D, the value of t in seconds when the velocity of the sewing is 11 cm per second. So when the v equals to 11, 8t minus t squared plus 20 equals to 11. So we have a quadratic equation. Make it in general form, we get t squared minus 8t minus 9 equals to 0. And factorize the t squared minus 8t minus 9, we get t plus 1 times t minus 9 equals to 0. So t plus 1 will get us t equals to negative 1, that we can ignore it because the time cannot be negative. So the answer left is only t equals to 9 seconds. Thank you.